To the stage, Dominic Williams, founder and chief scientist at the Dfinity Foundation. Let's give him a warm welcome back.
Thank you. Hello, everyone. First of all, just thank you so much for coming. It's really appreciated. We've had amazing guests, and thank you to them and the amazing team that's put this all together. And hopefully, you'll remember someday when we do more of these that you came to the first World Computer Day. All right, so I haven't got much time, so I'm going to go straight into this. And we're going to talk about the self-writing internet. I'm going to go through quite a few slides, some slowly, some quickly. We'll skim over some of the more technical pieces. And hopefully at the end of this, you're going to, A, understand what the self-writing internet is, and B, understand some of the technical challenges involved and how we at the Dfinity Foundation have been approaching them. So title of this is Self-Writing Internet Unlocks 8 Billion Imaginations. The idea is that anyone on Earth who can speak natural language can create websites, web applications, and internet services without doing anything other than speaking. And of course, that's because AI is building. And the internet computer and internet computer protocol provides it with an ideal platform to build solo. So what's the world going to look like? What's the internet going to look like tomorrow? Maybe not quite tomorrow, but soon. And this is what we're going to get. People are going to chat with AI to create running web apps and internet services. And this is going to be a very broad paradigm. An individual might create a personal branding website or a portal for their club or a wedding planner. An entrepreneur or a small company might create an e-commerce website, an AI-driven social media site, a sharing economy app with Web3 Rails. This goes right across to, SMEs and corporations and government departments who might want to create corporate portals or CRM, ERP, ARP functionality, that kind of thing. And there really is no limit to this. AI is going to get better and better at building, and the trick is to give it a platform to build with. So in this paradigm, you'll talk to the internet, and sure well later on a URL, there will be the website, web application, or internet service that you described and asked for. But of course, this is a never one-shot process. You're going to want to use that in production and continually evolve it. So the paradigm will allow for that. You'll continue talking to the internet in a way, talking to an AI built into the internet, and you'll keep on just refreshing the URL to see the changes, and you'll be able to update and improve and evolve running web applications and internet services that have, a few users, hundreds of users, thousands of users, or even perhaps millions of users. This screenshot here comes from CFC, actually. We actually did a live demo, and on stage, bravely, because this is like a beta without a lot of pieces, I'd say create a web application that helps a tech startup recruit talent. It should make it possible to enter open positions. It should make it possible to enter candidate details. It should be possible to add comments to open positions and candidates. It should be possible to vote on candidates, make it sexy. And it basically deployed it, gave me a URL on the internet computer, which of course is accessible in any web browser. It could also be a progressive web app if you prefer that. And then I think I told it to change the title to Acme Talent Hunting. And with less than 2 minutes work, this is what I got. And, on stage, I added myself as a candidate, Don Williams, thinks a lot of himself, voted myself down, experienced too much, many years in tech, and Collins does no stuff though. But that was, less than 2 minutes. And you can imagine if you just kept on talking, potentially you could create something really useful. And when you think about how, for example, many businesses, sign up to services like Salesforce, which are very expensive, and employ teams of consultants to customize those services and so on, and the data gets stuck inside the services, you can probably see that not only does this massively reduce your time to market, it massively reduces your cost, your data isn't held captive, and you can just keep on talking to get exactly what you want. And the only limit really is, how sophisticated this becomes. Now, something else I should mention about the self-writing internet, it creates apps with benefits, right? The self-writing internet isn't something that builds on traditional IT. It can do and it will do, but there are issues. So with the self-writing internet that we pursue, when people talk to the internet to create an app, it's sovereign. It's hosted on an open network stack, and the creator of that app owns the underlying code, even if they don't modify it themselves, and they own all the data and they have complete freedom. It's tamper-proof, and tamper-proof means that the website, web app, internet service that you created is immune to traditional forms of cyber attack. You don't need any cybersecurity. It's not necessary. No firewalls, no anti-malware, no anti-intrusion logging or anything like that. And that's actually a great advantage, obviously, if you're just talking to the internet and being given this thing. Like, you don't have to hire a cybersecurity team to protect it. And lastly, and last but not least, and this is a subtle one, it's updatable. So one of the most tricky things with the self-writing internet paradigm is that, of course, people want to update their apps in real time and improve them over time, often while they've got users. So it's difficult to upgrade running applications at the speed of chat. And it's also very important that the AI doesn't make a mistake, hallucinate, and resulting in the loss of data. That just cannot happen any more than the things should be hackable. So this new self-running internet paradigm that we pursue, essentially the Internet Computer Protocol platforms solo generative AI. And artificial intelligence is empowered, and you're just combining advanced LLM technology with a platform that's designed to enable AI to build. Now, the Internet Computer is a world computer. It's designed to allow developers to build, of course, and it's designed to do many other things too. But we've been working on technology that makes it much easier for AI, much safer for AI to build solo. And we'll come more to that in a moment. So before we talk more about how Internet Computer Protocol and Motoko, particularly a language designed for AI, supports it in building solo, we cover quickly some of the challenges with current IT with respect to enabling AI in this way. So current IT, I mean, what you think of as IT today, like a cloud service, an operating system, a database, a web server, memcached, all applications and all that stuff, cybersecurity. It has sort of unbounded nuance and detail. And one way of kind of grokking that is just to sort of go online or go onto Amazon and look at the sheer volume of technical documentation involved. Hundreds of millions of pages covering just about everything you can imagine. How to optimize the database so it runs faster, how to configure the operating system so that it's more secure. And that's one of the reasons that today, engineers often spend like 95% of their time chasing complexity, only 5% of their time focusing on what. And that, as it turns out, is not great for AI. The other problem, of course, is security. So, today we build systems that are fundamentally insecure. And then we try and add security with cybersecurity. So, we'll protect our network of databases and web servers and things like that with a firewall. And then we'll try and stop malware getting inside with anti-malware, so we don't get ransomware on a network. And we'll have anti-intrusion software to see if somebody succeeded in getting behind the firewall. But the problem is that traditional current IT is insecurable. And the sort of deeper reason for that, if you're wondering, is that essentially it's a stack of software running directly on silicon, and all you can really do is patch holes. So, this isn't an ideal environment for AI to handle, because if it hallucinates and makes a mistake, it can result in hackers getting inside. So, generally speaking, when AI builds solo on current IT, a hack is, one hallucination or mistake away. Current IT can't upgrade at chat speed. I mean, we all know how long it takes to upgrade systems built with traditional IT, and that's a problem. But also, if it makes a mistake during a sort of migration of the data can be lost, and that's an absolute showstopper. Current IT installs and admin are slow, and tasks involve problem ladders, like you need to upgrade the database, but then you find that it needs a new library, and that requires the next version of the operating system. This isn't chat speed stuff. And then lastly, of course, like the complexity of current IT platform stacks makes successful one-shot coding by AI very, very difficult. So those are the big problems. We've covered them. ICP, how does that work? Well, within the permissionless sort of public setting, it's used to create a world computer platform called the Internet Computer. And the great thing with this is that you just upload code to create and update. And that suits this purpose. And Internet Computer Protocol addresses tech fragility. So today, we build in a centralized way in perhaps one data center. It's complex, it's vulnerable to cyber attack. And, we get hints of the complexity. For example, like CrowdStrike security, was that last summer? There was this security patch and it went wrong and it crashed 8.5 million systems and they couldn't be rebooted. So that kind of thing obviously requires centralized control, because you've got to physically fix problems like that. And back in the sort of time of COVID, East Coast Amazon Web Services data center went down and the New York subway stopped working. In the future, of course, there's not just crashing software and hardware failures and data center fires and things like that, but we have to think about state sabotage and drones flying into data centers. So Internet Computer Protocol changes the way that the tech stack works, if you like. It creates a completely new kind of tech stack. And this involves data actually and computation being replicated across multiple data centers. So first of all, there's a virtual execution environment. And when you go to a web page with your browser, you don't worry that the JavaScript in the web page is going to jump out onto your computer and do something bad to your laptop. And that's because the JavaScript is running in a virtual execution environment. One of the innovations of Internet Computer Protocol technology is that it puts an entire cloud computing environment into a virtual execution environment. And then that thing exists within a network, a secure network protocol, which gains its security from math and math proofs and things like that. And actually the hardware in these different data centers doesn't run software directly, it just processes Internet Computer Protocol. And as a result of hardware in these different data centers processing Internet Computer Protocol, you get this incredibly resilient, tamper-proof, serverless cloud computing environment. And this is an environment that's absolutely ideal for one-shot AI, because all of the complexities associated with things like code crashing and failing and being unavailable are gone, as well as some other things. So these complexities are gone. The AI can just code, upload this serverless code, and a short while later you've got this experience being made available. And these apps that it's creating are tamper-proof, which means they don't need protecting by cybersecurity. They are immune to traditional forms of cyber attack. They're unstoppable, so the AI doesn't have to manage things like failover and backup in the same way. And the other piece to mention is that the code that the AI writes and uploads to Internet Computer Protocol platforms is very, very highly abstracted, which is which is ideal for AI again. So we're going to skim some of this stuff, but to give you an idea of how abstractive, on Internet Computer Protocol platforms, networks, logic and data are kind of the same now. So this is a big innovation. It's called orthogonal persistence. And here you can see there's a blog post, and we all know what a blog post is, right? It's defined type post, title text, and body text, okay? And in order for the AI to define a blog, it just says, var posts, post equals array of posts. So that's it. So you can probably see, even if you're non-technical and have never written a line of code in your life, that this is almost certainly vastly simpler than what you'd have to write with traditional IT. So again, we'll skim this, but one of the big tricks with this platform is, number one, when the code is updated. So when you have a current application and the AI extends that underlying code to add new features and has to perform a migration of the data associated with web application, the technology firstly allows that migration to occur extremely quickly, and secondly, has what we call loss-safe logic. So the AI will write some upgrade logic, migration logic is part of what it's doing, and here in this example, it's just added some likes, a likes field to the blog post, and when that's uploaded to the network actually checks that the migration logic wouldn't lose any data by accident unless the AI has explicitly said, drop that data. And this is incredibly important because if you think about, AI is getting very good at writing code now, but using AI to run websites and web applications and internet services completely solo is much more challenging, because in this paradigm, the self-writing internet paradigm, people just continue talking to the AI to upgrade and evolve what they have. And it's obviously essential that if there are people using it, that their data isn't lost. Okay, so what does this mean? In practice, nobody knows. I mean, tiny cost, massive speed, huge gains. That demo I did at CFC, it was less than 2 minutes. I don't know how long it had taken me to code that. A day, longer than a day. The fact that was done so quickly probably means that the cost is less than 1% and the speed is more than 100x. And this thing it can produce scalable apps, efficient interoperable apps, and also these apps can pack things like Web3 and AI functionality, and they're decentralized. You're getting something that's sovereign. Last question, since we're here at Davos, this is the kind of elephant in the room. People say when they look at this technology working, damn, are all software engineers going to be put out of business? The answer, I think, is actually no. It's a bit like the internet is going to generate more jobs. So, the self-writing internet empowers 8 billion non-technical people, and some of them will enter roles in tech. They'll become prompt engineers, they'll become tech entrepreneurs, they'll help run online communities that are being created. And humanity will now create, as this gets going, millions of new custom apps and services. And, a subset of those are going to require professional human assistance. So that's more work for software engineers, user experience designers, and things like growth hackers. So there you go, this Internet Computer Protocol. It's probably not hyperbole to say it's the most sophisticated network protocol ever engineered. It aims to democratize and decentralize. I'm Dominic, I work at the Dfinity Foundation. We aim to be a sort of NASA for decentralization. We're headquartered in Zurich, but we team members all over the world. And thanks for listening. If you need to get in contact, please use these details. Thanks.